No pursuit has ever been more significant to science than understanding how the universe arrived, how it works, and how it will end. We find it hard enough to plan ahead of the weekend, but some scientists have mapped out what will happen to Earth and the universe's major events all the way to the googol years from now. The distant future will bring plenty of good news and catastrophes too, but it's all worth considering if it can remind us to appreciate what we have now and work harder to sustain it. On that note, here's Earth's centric peek into the faraway distant future. "100 years from now, a sweaty century. Earth continues to heat up, possibly 10.8 degrees Fahrenheit from today's average temperature. This could lead to twice as many very intense Atlantic hurricanes, a 15% drop in the northern hemisphere snow cover, and a 2-foot rise in the global sea levels. The Arctic Ocean is ice-free in summer, amplifying the climate change even further. 200 years from now, live long and prosper. Human life expectancy is now 87 to 106 years, and while population growth has slowed, there are still nearly 10 billion of us. Climate change has killed many people and driven the key wildlife species to extinction, collapsing many ecosystems, and the CO2 emissions are still in the atmosphere. But technology has also offset some climate-related problems, improving crop yields, healthcare, and energy efficiency. 300 years from now, humanity makes it to the big leagues. Created by Soviet astronomer Nikolai Kardashev, the Kardashev scale ranks advanced civilizations based on their energy sources. Type 1 uses all the available resources on its home planet. Type 2 taps the full energy of a star. Type 3 harnesses the galactic power. US physicist Michio Kaku has predicted humanity will be Type 1 civilization by the 2300s. 400 years from now, superhuman powers are available to common citizens. The nanotechnology of recent decades has conferred powers to citizens that would be considered superhuman by 21st century standards. These upgraded transhumans could perform feats regarded as godlike to denizens of the early times. In many ways, they would resemble a comic book superhero or a video game character. 500 years from now, Mars has been terraformed. By the middle of this millennium, the red planet has been turned from a cold, dead world into a lush Eden-like paradise. This monumental achievement was the result of human collaboration on a planet-wide scale. It created whole new industries and undreamed of technologies. 600 years from now, plastics and other waste products are disappearing from Earth's biosphere. Most of the plastics, tin cans, and other waste products from the 20th and 21st centuries have decomposed by now. They cause significant harm to the environment during their time on Earth, injuring millions of birds, fishes, and other animals. 700 years from now, Venus has been terraformed. By now, Venus has been terraformed into a habitable Earth-like world. The planet's entire orbit was shifted, bringing it closer to the Goldilocks zone, while its day and night cycle was accelerated from 117 days to 24 hours. 864 years from now, Duck. The asteroid 950 Da will pass scarcely close to the Earth on March 16, 2880. Although a collision is possible, NASA predicts it will narrowly miss, providing an important reminder of what's to come. 1,000 years from now, Duck even more. Thanks to ongoing human evolution, people of the year 3000 may be 7-foot giants who can live for 120 years, and sexual selection has likely also made them more attractive. 2000 years from now, pole positions. The planet's north and south magnetic poles periodically reverse, with the last switch occurring in the Stone Age. It may already be underway again in 21st century, but since it's a slow process, the North Pole probably won't be in Antarctica for a few millennia. 8,000 years from now, Dancing with the Stars. As if pole reversal wasn't confusing enough, gradual changes in the Earth's rotation have now dethroned Polaris as the northern star, replacing it with Deneb. But Deneb will later on be usurped by Vega, which will give way to Thuban, eventually setting the stage for Polaris to regain the role in 26,000 years. Navigation hasn't been this hard since Apple Maps. 10,000 years from now, the hypernova of Attribution is affecting our region of the galaxy. Attribution is among the largest, most volatile stars in our galaxy. Its temperature is so high that it is unable to hold on to its own gas, with constant streams being ejected from the surface. For a brief period, this colossal explosion outshines the entire galaxy. It is bright enough to be visible during daytime on Earth, while at night it is similar to the full moon. 22,000 years from now, the Chernobyl disaster site has become completely safe. The Chernobyl explosion, which occurred in 1986, was the worst nuclear accident in history, affecting tens of thousands of square kilometers of land. Radiation at the center of the former disaster zone has decayed to negligible levels by now. 35,000 years from now, Ross 248 becomes the closest star to our Sun. Ross 248 is a red dwarf with approximately 12% of the Sun's mass and 16% of Sun's radius, but only 0.2% of its luminosity. In 2010, Ross 248 was 10.3 light years from Earth, with radial velocity of 81 km per second. By 35,000 years from now, it is closer than Alpha Centauri. 40,000 years from now, Voyager 1 is passing near the red dwarf star, GLIESE 445. Launched by NASA in 1977, the Voyager 1 space probe continues to drift through interstellar space. It is now passing near GLIESE 445, an M-type main sequence star in the constellation of Camelopardalis, close to Polaris. 50,000 years from now, cooling off period. Unless excess greenhouse gases are still scrambling Earth's climate, the current interglacial period finally ends, triggering a new glacial period of the ongoing Ice Age. 100,000 years from now, Canis Majoris goes wild. The largest known star in the Milky Way has finally exploded, producing one of the most spectacular supernovas in galactic history. It's visible from the Earth in daylight. 2,000 years from now, the night sky reinvents itself. Due to the proper motion or the long-term movement of celestial bodies through space, familiar star constellations like the Big Dipper, Orion and Perseus no longer exist. 250,000 years from now, Hawaii has a baby. Loihi, a young submarine volcano in the Hawaiian chain, rises above the Pacific Ocean's surface and becomes a new island. 298,000 years from now, Voyager 2 is approaching Sirius. Voyager 2 was an unmanned space probe launched in 1977 to investigate the outer planets of the solar system. The probe survives for thousands of years in the emptiness of interstellar space. It eventually passes by Sirius, having covered a distance of over 25 trillion miles. 1 million years from now, Betelgeuse has become supernova. Arguably the most famous of the red supergiants, Betelgeuse forms the top left part of the Orion constellation, 640 light years from Earth. By 1 million years from now, it has erupted into a Type II supernova, bright enough to be seen during daylight hours on Earth. 1.4 million years from now, constant comets. Orange dwarf star GLIESE 710 passes within 1.1 light years from our Sun, causing a gravitational disruption in the Oort cloud. This dislodges objects from the solar system's icy halo, possibly sending a barrage of comets towards the Sun and the Earth. 2 million years from now, Pioneer 10 is approaching the ALDEBARAN system. Pioneer 10 was the first space probe to travel through the asteroid belt and to directly observe Jupiter, which it passed by in 1973. After completing its mission, it began heading in the direction of ALDEBARAN, a red giant star located 65 light years away in the constellation of Taurus. Attached to the probe is a pictorial message, in case of interception by any extraterrestrial life. This plaque shows the nude figures of a human male and female, along with symbols that are designed to provide information about the origin of the spacecraft. 6.8 million years from now, DNA from 21st century is completely decayed. Even if we preserved under ideal storage conditions of -5 degrees Celsius, every molecular bond in a strand of DNA will decay after 6.8 million years. Any remaining biological samples from the 21st century which have not been recovered or digitized are now completely destroyed. 7.2 million years from now, Mount Rushmore has eroded away. Due to absent human intervention, the famous faces of presidents carved in the side of this rock formation have disappeared by now. Granite has an erosion rate of approximately 1 inch per 10,000 years. 7.6 million years from now, Phobos is ripped apart by Mars' gravity. Phobos is the largest and the closest of two moons of Mars. Because its orbital period is shorter than Martian day, tidal deceleration has been decreasing its orbital radius at the rate of about 20 meters per century. By this date, it has passed the Roche limit. Phobos begins to break apart. It gradually becomes a ring system over the following 3 million years. 8.4 million years from now, LAGEOS 1 returns to Earth. LAGEOS 1 was predicted to re-enter the atmosphere in 8.4 million years. It contained a plaque designed to allow future descendants of humans to view the arrangement of Earth's continents in the past, present and future. 30 million years from now, where's Bruce Willis? An asteroid of 6 to 12 miles wide typically hits Earth every 100 million years, and the last one hit 65 million years ago, killing off the dinosaurs. Another is thus expected in the next 30 million years, releasing as much energy as 100 million megatons of TNT. It would blanket the planet in debris, spark widespread wildfires, and trigger a severe greenhouse effect. Dust in the sky would also block out the sun for years, hindering plant growth. 50 million years from now, C-. Africa collides with Eurasia, closing up the Mediterranean Sea and replacing it with Himalayan-scale mountain range. At the same time, Australia is migrating north and the Atlantic Ocean continues to widen. 80 million years from now, Saturn's rings fall apart by now. Over time, they are slowly being bombarded by micrometeorites. Trillions of tiny collisions eroding their structure and darkening their appearance. Material was also being liberated by charged particles emanating from the magnetosphere. Combined with gravitational influence of the moons, by 100 million years, Saturn's rings have largely disappeared. 225 million years from now, the Sun completed one galactic year. By now, our Sun has completed another clockwise revolution around the Milky Way galaxy, the 21st in its lifetime so far. 250 million years from now, continents unite. Continental drift once again smashes Earth's dry land into a supercontinent, which resembles the ancient Pangaea. Scientists have already named it Pangaea Ultima. 600 million years from now, Earth needs some shade. The Sun's growing luminosity increases the withering of surface rocks, trapping carbon dioxide in the ground. Rocks dry up and harden due to faster evaporation of water. Plate tectonics slow down. volcanoes stop recycling carbon into the air and CO2 levels begin to fall. This eventually impedes C3 photosynthesis, likely killing off most of the plant life. 720 million years from now, the Sagittarius dwarf galaxy has been absorbed into Milky Way. The Sagittarius dwarf elliptical galaxy is a tiny satellite galaxy orbiting the Milky Way. For eons, it has been stretched and torn apart by the immense tidal forces of its neighbor. By now, it has been completely absorbed into Milky Way. 800 million years from now, multicellular life dies out. The ongoing decline of carbon dioxide levels makes C4 photosynthesis impossible. Unless humans have devised some kind of geoengineering scheme to preserve the food web, Earth's biosphere is reduced to single-celled organisms. 1 billion years from now, Earth can't hold water. The Sun is now 10% more luminous, heating up the Earth's surface temperatures to an average of 116 degrees Fahrenheit. The oceans begin to evaporate, flooding the atmosphere with water vapor and sparing an extreme greenhouse effect. 2.8 billion years from now, Earth is dead. Earth's average surface temperatures rises to nearly 300 degrees Fahrenheit, even at the poles. The scattered remains of single-cell life will likely die out, leaving Earth lifeless for the first time in billions of years. 4 billion years from now, welcome to Andromeda. There is a good chance the Andromeda galaxy has collided with the Milky Way by now, starting a merger that will produce a new galaxy called Andromeda. 5 billion years from now, the Sun is a red giant. Having used up its hydrogen supply, the Sun grows into a red giant with a radius of 200 times larger than today. The solar system's innermost planets are destroyed, and Earth is suffering under the extreme temperatures of its red giant Sun. 8 billion years from now, Titan seems nice. The Sun has completed its red giant stage and may have destroyed the Earth. It is a white dwarf now, shrinking to nearly half its current mass. Meanwhile, rising surface temperatures on Saturn's moon Titan might be able to support life. 12 billion years from now, the Sun is a black dwarf. With its main sequence life at an end, the Sun cools and dims into a black dwarf. 100 billion years from now, the Virgo supercluster is converging into a single galaxy. The Virgo supercluster, containing hundreds of smaller clusters, including our own, is now so ancient that it has begun to stabilize and converge into a single huge galaxy, many millions of light years across. 1 trillion years from now, peak stardust. As supplies of star-producing gas clouds run low, many galaxies begin to burn out. 2 trillion years from now, galaxies beyond the local supercluster are no longer visible. Dark energy has continued to drive the expansion of the universe at an ever-accelerating rate. By now, the volume of the universe is so great and the speed of acceleration is so high that everything beyond the local supercluster is no longer visible. 20 trillion years from now, red dwarf stars are dying. By now, even some of the largest lived stars in our galaxy, such as red dwarfs, have begun to fade away, leaving behind only cold black dwarfs, emitting trace amounts of radiation. 100 trillion years from now, the end of the stellar era. Star formation has ended, and the last main sequence stars are dying, leaving only dwarf stars, neutron stars, and black holes. Black holes gradually eat any remaining rogue planets. 10 undecillion years from now, a bunch of degenerates. The stellar era yields to degenerate era, as the only energy sources are proton decay and particle annihilation. If humans still exist, hopefully we have good flashlights. 10 trillion years from now, back in black. The black hole era begins, populated by little more than black holes and subatomic particles. Due to the universe's ongoing expansion, even those are hard to find. Google years from now, a shot in the dark. After many eons of black hole evaporation, the universe is a sparse junkyard of photons, neutrinos, electrons, and positrons, separated by inconceivable long distances. An array of theories speculate what will happen next, including the big freeze, the big rip, the big crunch, and the big bounce. Not to mention the idea of a multiverse, but it's widely believed our universe will expand forever. Thank you so much for watching, everyone. I hope you enjoyed this video, and if you did, there are a couple of ways to let me know. You can give this video a like and comment down below, as it will help me a lot for my future content. Also, you can subscribe and follow me on Twitter and Facebook if you want to see more of these types of videos. Thank you once again for watching, and I'll see you guys next time.